Welcome to this feedback video on assignment 3 to 5. Assignment 2 has been dealt with in the previous feedback video, so check out that video about the disassembly photo and video. You really worked hard on disassembling your products. Some very nice, simple and easy to dismantle products like the Nutcracker from Tom, and some were very extensive with lots of components. Maybe too many for the time you have in this course. It's good to see the eagerness for learning in the products you showcase. So today we're going to give you feedback on the hotspot mapping and on the disassembly mapping. So first of all, we will give you an overview of your shared work. Check out the Miro board online and see what your fellow participants are working on. And don't forget to give one of your fellow participants feedback on his or her work. You can do this in the last part of the Miro template. We will discuss three main questions about the difference between parts and sub-assemblies, about timing of the different disassembly activities, and about taking into account screws, yes or no. After these questions, we will discuss some showcases from you and your hotspot and disassembly maps. Unfortunately, we don't have time to discuss all of them, but we also try to give you feedback via the Miro board itself. We will finish this video with some key takeaways and the upcoming assignments in which you go more into depth of the value recovery potential of your case product. So here you see an overview of your disassembly maps. You see people working with sticky notes, which is very handy for sketching out the disassembly tree, making it easy to shift the nodes during the process of making the final map. And of course you can finalize your map by using software. After finishing a sketch using sticky notes, this is a perfect way of visualizing the ease of disassembly in a more presentable way and actually make the hotspots visible in the map. It will draw your attention to the priority activities and the priority and valuable parts. So there were three main questions asked in the forum, but also on the Miro board. The first question concerns the definition of part or subassembly. In general, a subassembly is a group of parts that can be removed from the product together and can then be taken apart into individual parts. As described in the hotspot mapping manual, every object which cannot or will not be dismantled any further is defined as a part. They often consist of single material objects, but of course mixed material objects which are more difficult to dismantle any further due to glue or press-fitted objects are in theory subassemblies, but can be defined as a final part. So in this example you see that both the bucket unit and the pedal unit are a subassembly, referred to by the yes in the subassembly column. And both subassemblies are part of the main assembly. And you can choose the part of by using the pull down menu. In step number 3, the handle is disconnected, which is defined as part by means of the no in the column, and which is part of the bucket unit disconnected in step 1. A defined disassembly can never be part of its own subassembly, like in the example of the Teco acoustic panel, where the chipboard is defined as a subassembly and is part of its own subassembly, the chipboard. Of course, this subassembly is part of the main assembly, and you have to make a choice between the available predefined subassemblies by using the pull down menu, and don't type in a name over there. So there is a pull down menu which you can make a choice of the subassemblies previously defined. Please bear in mind that if you define a unit as a subassembly, both the functional sensitivity and material properties function columns are all grayed out. This is for a reason. It means you should not fill in any of these cells. If you are filling in values or numbers though, this will have an effect on the different performance indicators, like the environmental impact and the economic value of this sustainability, the subassembly. This means that the parts which are part of the subassembly and which are entered underneath will be taken into account twice and therefore contribute twice for both the performance indicators. These doublures will disrupt the red flag system and of the KPIs and give you wrong output about the importance of part or subassembly for the ease of disassembly. So delete all values or content in those grayed out cells. When you define every disconnected unit as a subassembly, the hotspot mapping spreadsheet will look something like this. You can also see that this participant filled in all grayed out cells, which again will frustrate the 5 performance indicators. In the subassembly property column, please choose yes when it's a subassembly and which you dismantle further in a later stage, and no when it's a part. Bear in mind that the subassembly is always disassembled further in a later stage. Last year there was also a question about what time to log. The first time it takes a while before you know what to log. This is most similar to DIY repair, when you're finding stuff out without having access to repair manuals or exploded fuse. The second time will be much faster because you know what to do. This equals to service repair. Depending on your focus, choose which fits best of your likes. If you're consistent, then in the end the task which looks the longest always comes forward. Which took the longest always comes forward. Both ways don't take time to inspect on how things are connected into account for the time to disconnect. Having a video of your teardown is always helpful in returning the time needed for every activity. So one of the third question is about, in the forum, concerned the way you should handle screws, nuts and bolts. There are 2 ways to deal with screws. You can add them as a part and take them into account in the hotspot mapping tool and even weigh them, or you can leave them out as part and just you unscrew 2 parts from each other and the fastener is a screw. I prefer the first approach, where screws are taken into account as parts of the product assembly. In this way, when screws are red flagged in either one of the 5 performance indicators, you know this is an important part. In larger assemblies, the influence of screws, nuts and bolts are on average very low on the performance indicators. But in smaller objects, like for instance a bicycle tail light, it can become a priority or a valuable part. Arno disassembled a cross-sorter deck. As we can see, the first steps concerns a lot of serial steps, followed by 2 branches, and he used different colors in a smart way to indicate the different tools used. When going deeper in the product architecture of the product, Arno found out that the rollers that were part of the cross-belt subassembly were separable and therefore needed to be cut out. By mapping this, Arno now knows exactly which part he needs to redesign. Robin dismantled also a cross-sorter carrier, and the process of dismantling actually opened up his eyes in terms of maintenance and the process of recovery. By slowly dismantling a product, you learn so much that this process alone is worth so much. By doing this more often in a slow fashion, you will learn how parts are connected, how problems in these processes come about, and of course how to come up with solutions, which makes the disassembly process more easy. By more disassemblies, you become more a circular designer. One of Tom's key takeaways was that bringing down the material weight would add value to the circularity. Hotspot mapping shows the materials with the highest values and the highest embodied environmental impact. And by bringing down the weight of these components, this hotspot will only shift to another part with higher weight. Hotspot mapping only prioritizes parts where heavier parts are made out of more valuable materials like metals will come forward, and other lightweight and low value parts will come, like plastics, will not. So in a sense, you're just shifting the hotspots when you're lowering the weight, which is not always good for circularity, because when a product becomes lower value, the chances of being recycled is low. So this example of Sarah shows the importance of weight and materials. Metals have a higher economic value and a higher embodied environmental impact than, for instance, plastics. Electronics have an even higher value and embodied impacts than metals. So mostly electronics parts, like the electromotor in this case study, but also metal parts have red flags and thus are highly valuable parts. These parts should be easy accessible, so if they are deep in your product architecture, you could redesign the architecture, making these parts more accessible. After finishing the hotspot and disassembly map, one of Sarah's key takeaways was that taking into account disassembly during the design phase might even be crucial to minimize cost of repair and maintenance on the long run. Thanks for sharing this insight. When you design new stuff, you do not take into account only initial material and assembly costs, but could take into account the life cycle cost, making the product last longer at a lower price. Based on a hotspot analysis on the disassembly tree from Robin, you can pinpoint how deep hotspots are seated in the product architecture. When these priority or valuable parts are seated very deep, it is better to redesign your product architecture and make those valuable parts easy accessible. You can make use of the 3 design strategies, surfacing, clumping and trimming, as described in the hotspot mapping manual. Over here you see an excerpt of this manual where we use the metaphor of pancakes and how to improve your product architecture by means of surfacing priority parts to the surface. So this was assignment 3 to 5. Take your time to finish this episode, and hopefully the tips we gave you during this feedback session were helpful. In the upcoming week, we will guide you through the next episode, episode 3, where you will be introduced to the circularity calculator. You will need the bill of materials for this, which you can take from the hotspot mapping spreadsheet. And if you don't know what specific material is used, guess what it is. For the experience of the tools used, it's not so important, and you can update this always at the later stage. Ingrid has made a guided exercise where you will be led through the tool. So please follow this simple but enlightening case. Assignment 8 and 9 are at the core of the analytical work for this episode, where you will be using your own case study as the showcase. Assignment 10 will bring everything together for the next episode. Don't forget to check the Miro board for feedback on your work, and of course to see a great overview of all the work of your fellow participants. Feel free also to comment on other people's work. You are asked to even give feedback on one of the participants' products, so please do so. Good luck finishing episode 2, and good luck with the start of the next episode.